Okay, welcome to Chapter 2. And in this chapter, we're going to pick up where we left off on parent functions, and we're going to really focus in on one of those parent functions called the quadratic equation. It is the parabola, U-shaped curve. We're going to talk in this lesson about transformations. We're going to revisit some things we did in Chapter 1. Let me just remind you that in Chapter 1, we did translations. Now, translations are slides. Vertical and horizontal, and transformations include translations. I know that's kind of confusing, but think of transformations as an umbrella, and underneath that umbrella is translations, but it also includes things like reflections, stretches, and compressions. And so we're going to take a look at that and expand our knowledge here. So let's start with the vertex form of a parabola. We will be studying this form and another form called standard form. This form allows us to really, intuitively look at it and tell where it's moved to. Whereas in standard form, you kind of have to work a little bit harder at it. But as you recall from Chapter 1, we have the number that's inside the parentheses with x. We never called it h in the first chapter, but we are in this chapter going to call it h. So let me help you remember that h and horizontal. And remember the x-axis is horizontal. So those three things connect together. I also want to point out that because of this negative right here, we talked about this in the first chapter, that the number that goes here is going to look like the opposite number that we put in there. So if we put in a positive 2, when we take a look at it, it's going to look like a negative 2. So keep in mind that your h is, let's just say it misbehaves. The k value, because there's a plus sign here, we're not going to have that issue. And so the k value makes the vertical changes, and it's, it does exactly what it's told to do. And the last thing, which we're not going to study in this video, is A, and this is where the reflections, stretches, and compressions come in. And it controls the direction and the width of the graph. I call it the commander-in-chief sometimes because of that, because it really does control the direction, the width of the graph. You kind of have to start there and make sure that things are falling in line. So let's define some things about a parabola. First of all, a parabola has a low point or a high point on the graph. Remember, it is U-shaped, and I'm going to attempt to do this here. It is U-shaped curve. And so it could possibly have these two shapes to it. The vertex will be a point on the graph that is either the highest or the lowest point. Okay? And then we have the axis of symmetry. And the axis of symmetry is the line that cuts the graph into two equal parts. So with that being said, it's a line, and I'll try and do this again very creatively, that cuts the graph into two equal parts. So if you fold it along that line, the left side will match the right side. Now keep in mind here, this piece right here is oftentimes overlooked, the x equals. So when you're naming the axis of symmetry, don't just say h or whatever that number is. You need to write it as an equation of a line, x equals. I know this is very picky, but if you leave that part off, it's wrong. Because the axis of symmetry is not a number floating out in space. It's a line. So you must write it as an equation of a line. Alright, so let's take a look at a couple examples. I know there's 10 on this page. I doubt if I'll do all of them, but let's look at a couple of them here. So in this exercise, we're going to be looking for the vertex and the axis of symmetry only. So again, we want to focus in on what's inside the parentheses with x and what's directly outside the parentheses right here. What we don't want to look at is that number there. So just ignore any number sitting out in the front of your grouping here. Alright, so the vertex is going to be xy, or hk. In this case, we have to think opposite. In order for that to have changed to a negative, we had to have a minus -1 there. So -1, -4 will be our vertex. The axis of symmetry is always the x coordinate, but we must add that x equals part to it. Okay? Let's do a couple more here. So we have, again, 2, -2. Now let's, again, make sure we understand that it looks like a -2 in the template, but it's really a +2. And then this is face value, so we will keep it -2. The axis of symmetry is always the x coordinate, so it's x equals 2. The next one would be -4, -3, x equals -4. Number 4, okay, let's just inspect this one. Notice that the -1/2 did not play a part in this answer. We're just looking inside the parentheses, okay, inspecting it. That was one time a minus, so it would be minus negative. So it's -2, 4. And that would be the answer. Okay, and the next one, I'm just going to run through these. I'm not going to explain them until we get to the last couple. All right. Now, on numbers 9 and 10, you'll notice there's no parentheses and there's no extra numbers out behind the x squared. So it does have a vertex. We just can't see it in this particular format because we don't need to have 0, 0 in there. So 0, 0 is the vertex and x equals 0 is the axis of symmetry. All right, same for number 10. Let's take a look. Oh, by the way, and I've already mentioned this, but the value of A does not affect the axis of symmetry of the vertex. And again, the value of A are all these numbers right here that are sitting out in the front, whether it be just a negative right there, or a -1/2, or a 1/2 here, or a 3 here. So let's take a look at sketching parabolas. Okay, so we're going to start with some steps here. You want to write these down. Locate the vertex and the axis of symmetry. Set up a table of values and evaluate 3 or 4 more points. And use reflection points, and I'll talk to you about that in a minute, and then sketch. So let's take a look at an example. The first thing we want to do is look at it, inspect it. What's the vertex? Where is the vertex? Okay, that's that point that we get from the template. And the axis of symmetry is that. And then you want to sketch that. And what you're going to see is that these two share the same real estate. The line of symmetry will always go through the vertex. And that's going to be key in sketching the rest of this because you can get some freebies out of this, freebie points. And I'll talk to you about that in a minute. So what we want to do is pick some points. That's the vertex. We want to pick some points either to the left or the right of the axis of symmetry. So I'm going to let x equal -2, and then I'm going to take that -2 and I'm going to run it through this template here to get the y coordinate. So -2 plus 3 is -1, -1 squared is +1, 1 minus 5 is -4. I'm going to plot that point, and this is where the line of symmetry will help you get your freebies. So there's a reflection point on the other side of that line. So imagine if you could take a paintbrush and paint that dot, fold it along that line. Where would the wet paint appear? And it would appear right there. Now, again, this doesn't give me a clear picture of the parabola, so I need to do a few more points. Once again, I'm going to use some points, and I can skip around, but it's probably safer just to go consecutively. I'm going to use -1. And I'm once again going to run that -1 through this template. When I add -1 with 3, I get 2. 2 squared is 4. 4 minus 5 is -1. I'm going to plot that point and then get my freebie. Okay, the next point I'm going to plug in is 0. I'm going to get 4 and then plot the point. That gives me enough picture for me to safely get it correct, so to speak, or get the shape of it correct. So I'm going to just try my best to hit every point when I do the sketch. All right, so that concludes this video. I will pick up in the next video to talk to you a little bit more about that number that was out in the front there, the value of A.